We'll find out in a second. Okay. Let's see. So let's talk in general about how it went with chapter 2 and 3. Who got stuck? Who had success? Yes?
I was wondering if we were supposed to implement chapter 3.
Implement. Define implement.
Okay, I mean, I read it a week ago, so I don't remember exactly, but I just remember that it wasn't clear to me how to actually go about, because on like chapter 2, it's obvious how to put it into Ruby code.
Yep.
But chapter 3, I didn't know how to.
I got to look at the chapter, but basically whenever they show, yes.
I was just gonna say, chapter 2, I thought was really good.
Yep.
It helped me connect like all the Rails with all the HTML. And
Yeah.
just like bring it all together.
Yeah, yeah, good. So I think chapter 3 is which one? Remind me. It's the one that says, oh, it's general stuff.
Yeah,
There's not a lot of code to type in. I mean, just, as I said several times, the exercise is just, you learn better by typing, and it makes sure your brain is engaged. And if you're on the treadmill or weightlifting at the same time as you're reading it, I'm not going to believe you actually understood it, and you're going to get stumped later. But, with that, I'm not so super picky, and neither are the TAs about exactly. We just want to know that you're engaged with the stuff, because it's really complicated. Okay? Okay. Oh, forgot, very important. I'm glad I made a note to myself. Everybody, stop everything. Get a scrap of paper out. It can be as small as a Post-it note, or as large as you want. I'm going to have only 3 minutes for this. It's not a test. Okay, I want you to write on a piece of paper things that you think I can change to make this course better, more effective, more interesting, more enjoyable. Things that you want me to keep the same or do more of, and any other comments you have. Don't write an essay, just give me a bulleted list. Okay, so you got the 3 things? If you want, yes, it's anonymous unless you want me to know who you are.
What if there's nothing?
Then just say, so there's nothing, nothing that I should change to make it, I should stop doing to make it better, nothing I should keep on doing or do more of to make it better, and no other general comments. Then give me a blank piece of paper and put your name on it.
Oh.
Actually, everybody's doing parallel, hand it to the middle to make it efficient. Okay, otherwise we'll take too much. Okay, and make it legible.
Okay.
All right, 3 minutes, really fast. Don't think too much. One minute to go. Do less of this, do more of that. Any other comments? You can also aim things at the TAs. Move to the middle. You have nothing?
Oh, I'm not actually in the class.
Huh?
I'm not actually in the class, I'm just sitting there.
Oh.
Yeah, so. What do you like?
You got an A. You're sitting in because?
I thought my pal was going to show up, but I don't think he's here.
Your pal is going to show up?
Yeah, but I don't think he's
What's your name?
Kuhar?
What's your major?
Bio, probably.
Probably. What year are you?
Sophomore?
Okay. Are you planning to take this course in the future? Depends how it goes today. Okay, got it. Yeah, thank you. Thank you, thank you, thank you, thank you, thank you, thank you. Thank you, thank you, thank you, thank you. Thank you, thank you, thank you. All right. All right. Thank you, sir.
That's the yellow one.
Here's the other one, okay. I'll remember that now. Thank you. Can you do a rough histogram of this? I mean, rough. You'll see themes, I'm sure, and so stick around. Thank you. Okay, who wants to tell me what an ORM is and why it exists? Yes.
It's a wraparound.
What does it stand for?
I'm object. I forgot.
Okay, you don't know. Great. What is it?
It's a wraparound a database. So instead of writing like manual SQL queries or depending on the type of database, you treat your objects like a graph rather than like an object.
Wait, speak up. I can hear you, but nobody else can. You can treat your objects like a?
You're able to treat your data as a graph rather than like a table of data.
Okay, not as a graph, but as a set of objects.
Yeah.
Anybody want to add to that? Or change that? It's totally contradicted. Yes.
So ORM is object relational model?
Mapper.
Mapper, okay.
Mhm.
So it's mapping tables in the database to classes in Ruby, for example. So every entry in that table would be an instance of that class.
Correct. Yep. Is ORM a Ruby concept? Is it a Rails concept? Anybody? Huh? What are you whispering?
It's a Rails.
Don't know what you're whispering? Okay. It is not. Okay, it's a Rails concept. No, actually, it's a general computer science concept. You will find them in all languages and for all kinds of databases. And the essence of it is that it's an adapter. It's basically, if you know the often misused term out of electrical engineering, impedance matching. It's an impedance matcher between a tabular repository that's persistent and takes an infinite amount of, it can occupy essentially infinite amount of disk space, and mapping it into a world of objects and instances of objects, thereby insulating the programmer who works in an object-oriented language from having to deal with the fact that the data is actually stored in a totally different way. And so you will have ORMs that are the front end or the interface to a relational database. You'll have interfaces to non-relational databases. And in essence, the purpose is exactly what he said, to create the illusion, because it's just an illusion, that the database is actually stored in a bunch of objects. It makes your life easier as a developer. And basically all these libraries, all these Rails and Ruby and all this stuff, their job is to make the developer's life easier, thereby allowing them to write more code, get things working better, more reliably, with higher quality. Okay? How about MVC? Who wants to take a crack at explaining MVC, other than tell me what the letters stand for? Anybody? Yes?
It's like an architecture,
Yeah.
so it means model view controller.
Yeah.
And it works with like, so for like a website, for example, it's a way of organizing the input and the output, where requests go to the website, and the controller sort of works with the input to figure out where it goes, and calls on the model, which is a state of data, and then displays it using the view.
Exactly. Anybody want to add to that? So again, that is an architectural pattern. We talked about patterns a little bit, that I think came out of the Smalltalk world. And architectural patterns are interesting in the sense that they help you as a developer or as an architect solve problems more quickly instead of having to reinvent the wheel. They also are the source of large religious battles, and so that's something to avoid, because people will get into big debates as to whether, MVC, whether websites or web architectures are truly MVC or they MVC or MVPC, and that's not really a very useful debate to have. Think of it more like a template. So when you have a blank piece of paper, it gives you an idea where to start. And we'll talk about this a lot more, so I'm not going to belabor it right now. But it's a really important fundamental concept. When you guys do the homework, do you read, because I think, is this useful? Yeah. Okay, because this is a new innovation in my curriculum, which is actually help point at the things that I think are useful in the things to look for, so you know what I think is important. the chapter is called Instant Gratification because the original, you can probably dig this up on YouTube, when Rails was first introduced to the world 10 years ago or something like that, the famous original demo was the original implementer of Rails showing how they could build a blog application in 5 minutes. And this was like so radical because everybody who had come out of other languages or other platforms thought that couldn't be done. And so the way they achieved that with Rails was this, first of all, package of code libraries, Ruby libraries, which embodied essentially best practices and or patterns that had been discovered in the process of developing lots of systems. The key characteristic of Rails-based systems, at least originally, was websites that had databases on the back end. Today it's a lot broader. And so they had identified all these patterns and all these best practices, and they turned them into a library that not dictated, but really put you on that's why they call it Rails, put you on a certain trajectory to building, let's say, a blog or any kind of like Trello or Facebook or any of those things. The salient characteristic of an oft-discussed and oft-debated about Rails is this phrase or this slogan, convention over configuration. Now, who has worked and built any complicated systems in Java? Quasi-complicated, non-trivial, yes. Okay, so what have you used in the past for accessing databases, for example, in Java?
I didn't do database.
Didn't do. Who did databases? Have you done databases in Java? Okay. Anybody done databases in Java? Okay. Yes?
We connected to like a SQL data, MySQL database with some driver stuff, and talks to it. I think we just bundled SQL commands into
Directly.
like these Java objects and then sent them in
Okay.
and got these Java
Well,
objects back out.
If you had done so, one of the problems would be that to access databases in Java, there is probably a dozen or more really popular libraries or frameworks to do that. And the first thing you have to do as a developer is to decide which one you want to use. So it's highly configurable. You can decide whether you want to use this, that, or the other library, but it gives you a big decision to make before you start working. The other side of the extreme is something that's very full of conventions. It says this is the one true path. Do it this way. Don't have to pick a database. Don't have to pick a web server. Don't have to pick a any number of security library. All these things, they're all picked for you, and you don't have to configure a lot of things, which means you can have instant gratification. You type a few commands in, and boom, you've got something running. Now the thing, how many of you succeeded in getting the instant gratification thing to run on your computers? So everybody else has failed. How about you? No. I'm going to pick on you. Yes. Did you succeed getting it to run? Yeah. Everybody? Who didn't? Who got stuck in the mud? It's very possible that you did. A little bit back there. Yes. Can you tell us what the nature of the stuckness was?
Yeah, I was doing PA movies too.
Pardon?
I was doing movies too. So I didn't really.
You didn't even do that?
I read through it. I haven't attempted it.
Okay. Okay. How about you? Did you try and get stuck in the mud?
Something wouldn't install, like either Rails wasn't installing properly,
Gotcha.
or JSON was missing.
Yeah. Yeah. This is yes. Go ahead.
What operating system are you on? Yeah, you have to install the development packages in order to get to it. I'm going to say it.
By the way, things like that, post them on the class forum, and you may get somebody to just give you the answer like this. Did you have? I thought I saw a hand. Okay. So I mean, this is the life of the software engineer. By the way, you've got the glory when you're inventing new B-tree, hypermapped, red, green, blah 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 algorithms, and that's like 1% of your time. And then 99% of your time is doing engineering, which is really, building large complicated machinery on top of large complicated machinery. I mean, I was like, when you open your iPhone, this is like a slight tangent, and you swipe. If you ever stop and think about what happens as a result of this swipe to lead that thing to move, it'll give you a headache. We build systems in a way that stacks abstraction on top of abstraction on top of abstraction on top of abstraction. The only way you can keep your sanity is you trust and believe that the guy below you is doing their job. Because you can't possibly keep in mind everything that happens all the way down. So the life of the engineer often is to make sure that each layer is doing what it's supposed to do. And when you first start, it's stupid things like getting the right version of Ruby, getting the right version of the gems, understanding how all this stuff goes in. In situations like this, Google is your friend, Stack Overflow is your friend. You know the old trick, if you get an error message you don't understand, copy that text, put it into Google, and chances are really good that you'll find somebody answering how that particular error message comes out. So don't be frustrated when you get stuck with these things, because this is the life of the software engineer. Is, you know, you got the glory, you got the patents, you got the intellectual property, and then you got the real work. And what you guys are experiencing now is the real work. Okay. Let's have a little brainstorm. I typed into my web browser box, I typed www.brandeis.edu, and I hit enter. I'm going to turn the screen off for a second and raise it. Oh man. Screen, raise. No, the light. Oh, yeah, here we go. And I want people to start calling out at the most micro level you want everything that happens between when I hit enter and when I see the Brandeis homepage appear on my screen. Okay? I'll get us going, just so you understand how this game is played. Okay, one thing that happens is the URL is parsed so that we can figure out what the domain name is. So it's locate domain name in URL. Go ahead.
Access server.
Sends the domain name to the DNS server.
Yep. Send. Okay, go ahead. Go ahead. Another one.
Get the IP
from
the server.
From
or the DNS cache.
From DNS. Yep. What happens next? Well, not next. It's any order. What happens? So many more things that happen. Come on. There's 100,000 more things. Yes.
Get like the local extension.
The local extension.
Like the part that comes after the .com.
Okay, so the path.
The path, yes.
Okay, get the path. Okay. Okay, go ahead. What else? Anybody else? Come on. 100 million more things. Yes.
Like automatically make a request to the server to take an action.
Okay. Yep. Absolutely. Yep. Request server to take an action. Yep. What's in that request?
Get.
Huh?
Get.
Get. Yes. An HTTP get. What else? Yes, go ahead.
Read the response header.
Well, okay, yeah, eventually you have to read the response, yeah. Go ahead, anybody else? Come on, a lot of people are quiet. Gee, what information is in that request? What does the server hear from the client? They heard the request is a get. Okay. Anybody else? Okay, the get also includes the path. So the server receives, it's over here somewhere. Server receives request, which includes server sees the path. I mean, when we say path, what we mean, just to drive it home, is http://brandeis.edu/cosi/cosi161b. Okay, that's a URL. So what we said over here is locate the domain name. That's that. Locate the path. That's this. Okay, send a get to the server, a get request to the server, including the domain name and the path. However, how do we know to send the request? What kind of message do we send to the server, and why do we decide to send that kind of a message to the server? Look at the URL. Because the browser parses this part, which says HTTP, and that's how it knows to ask the server using the protocol called HTTP. Okay? Okay, so what else? So now server sees the path, server sees the request. What happens next?
Does
Yes?
the server proxy change the path into an actual file location?
So you say the path changes to the file location, which is not exactly right. It's interpreted but it's not necessarily a file location. Obviously, this is not a file location.
No, yeah, yeah.
Oh, you just said that though.
No, the proxy translates that into like where that lives on the server.
Well, it doesn't. This does not live on the server anywhere. This is a request that goes into a search engine, so it goes into code. But anyway, I'm trying to make sure that yes.
Oh,
No, nobody else? Nothing else? Come on. Okay, there's a database here somewhere, I assume, that has all the course listings, right? Okay, so what happens? Really, everybody stumped? Come on. Automatic A. No, nobody? Okay. All right, so I'll go a little further then. So what happens is that the request using a protocol, and I'm going to take all this stuff slowly soon, I'm just doing it quick right now. The request gets sent with a protocol called HTTP, which includes the path. I mean, it doesn't have to include the domain name because the recipient of this request is the domain. So the server that's addressed by brand.edu receives this string and says, oh, what do I do with this string? And this string basically gets parsed by sort of the front end of the server, which we call the router, and it analyzes it and figures out how to cause the right bit of code to run on the server. What is that code? What gets returned? Nobody talks about what gets returned. So we send a request to the server. What does the server send back to the browser? Yes?
It renders HTML.
But yeah, usually. So the server renders HTML, which is another language, which we'll talk about, and returns that to the client, to the browser. The browser, what does the browser do with HTML? Talk about browser and HTML. What do they do? What's their connection? Somebody from this side. I think I haven't heard. No, I have heard one. Browser and HTML. What's the connection? Beep, 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 beep. Yes.
Well, the browser renders and displays the HTML file.
Yeah, the HTML is kind of like a programming language, and the browser is kind of a runtime system for that programming language. And what the result of executing some HTML is a picture on your screen. So the server returns the HTML over the network. The browser looks at HTML and displays it on the screen. Okay? So basically now we've said, drawing a picture, we have the browser. Let's draw it like this, where I type the URL. The URL gets sent to the server. We'll draw it like this, canonical server. The server, so this is a HTTP request, which is a protocol. It's basically a packet, and it returns back to the browser HTML, which is also a packet, and HTML is the payload of the packet, what's in that packet, and that packet contains text, essentially. HTML is just text, but when it gets back to the browser knows what to do with that and draws a picture. Okay? Now, if you look behind the scenes here, you would know that this server has in it somewhere a database which has all the courses in it, a list of all the courses. I'm asking for a certain course. It also has a list of all the, we call them page templates, which is like a little bit of HTML with a lot of blanks in it where data can be stuffed, which makes the header and the colors and all that stuff. So if you think about it, you have data out of some kind of database. We have templates, which contain a bunch of angle brackets. They're HTML. We have the server, which basically finds the right template in here with the right records, combines them in a clever way to make them into pretty HTML pictures, and sends them back to the browser. Okay? That's the first flyby. We're going to go over this a dozen more times, but I want to give you sort of the high-level, quick explanation. Okay? So the basic, I can turn this thing back on now. So the basic concepts we're talking about here is we all know the internet and the web works between clients and servers. What is a client? What is a server? They're both just computers. This could be a client, this could be a server. This could be a client. This could be a server. Okay? What is the difference between a client and a server? It's all in what you call it. A client asks for things, and a server gives things. A client usually has a human being behind it, looking at it. A server usually does not. But those are generalizations that are often do not hold all the time. So that's all a client and a server is. Okay? They're just two computers. One asks for things, the other one gives things. Then you have the internet. And the internet is basically a huge, as you know, world of nodes all over the place. They're connected in different ways. And each of these nodes is either a client or a server. Actually, very often it acts as a client sometimes, as a server some other times. Okay? These lines are a lot of things. They're basically first a piece of wire or a radio wave at the physical level. But then they also have specific rules about what kind of languages, what kind of protocols they can talk. And there's a lot of protocols, and I'm going to cover those as well. But basically, that's what we got. We got the client who's asking for a page. We got the server that's generating a page. And that happens through a set of requests. Okay? So there's three of the most important standards. Now, when I say standard, let's talk about that for a second. So data flies through computers. You all know CSV files, right? Comma delimited, comma separated values. Thank you. I never was sure what that. Okay, that is a format or a protocol. There's rules that say if I give you a text file and I say it's CSV, you'll know what to do with it. Similarly, if I connect two computers and I send bits across, there are rules that say if you see these bits, here's what they mean. I mean, one illustrative exercise is if I listened in on a pipe on a network cable and I saw this, and I said, can you do this, please? You'd go, okay, but I don't know what it means. Right? And that's what protocols are like. That's numbers going by, can you do this, please? But if before I sent this, I said, hey, by the way, what you're getting in the next 24 digits are 3 dates encoded as numbers, followed by a 1 or a 0 to mean whether it's a male or a female, followed by 6 more digits, which corresponds to their grade point average. Now this number would mean something. Okay? So a protocol is a set of rules that say, given some information, bits, let's say, or digits, let's say, or text, let's say, here's how you make sense out of it. All right? Now there's 3 critical protocols or standards or formats, which are all pretty much the same thing, that make up the internet, or the World Wide Web in particular. The URL, which is a format and a standard. The HTTP, which stands for Hypertext Transfer Protocol, which is how the client and the server talk to each other. And then finally HTML, which is a standard or a format which can take visual information and convert it to a textual representation. And those, although there's now dozens other protocols and standards that come into play, those were the original sort of legs of the tripod of the web. Okay, there was the original thing that what's his name in CERN came up with to build what became the World Wide Web. And so we have to understand those things thoroughly. To build each of your products, you're going to be able to like live, sleep, and dream HTML, HTTP, and URLs.
This is just like Tumblr.
It's just like Tumblr?
In terms of like building, because like in Tumblr, everyone makes their own customized web pages.
Yeah, exactly. And that's the whole web. Every single page you go to is like that. Okay? Now, a lot of things have happened since then, so it's a lot more protocols, but these are still the key building blocks. So I want you to understand it in your gut, what I mean by a standard, what I mean by a protocol. It's just this. Given a bunch of random numbers, what does it mean? Well, if I tell you I'm speaking in ASCII, and this is actually a person's first name and last name, now you can understand it. If I tell you instead, no, I'm a bank server, and this is account number and a current balance, now the same numbers mean something else. The standard or the protocol or the format are the things that establish the rules to interpret as well as generate legal strings in this language. Yes?
Isn't that like the same thing as a file format?
Yeah,
Like
exactly.
Some extension?
Exactly the same thing. I mean, they're all, let me put it this way, at an abstract level, it's the same thing, okay? At a detailed level, they're not.
That's why, like, if you open a doc file in Notepad or something, you just get like a hieroglyphs.
Yeah, exactly. That's exactly right. And this concept is it's fundamental to computer science, fundamental to engineering, it's fundamental to networking. The idea of a standard, because without it, I mean, you might have heard of, IPv6. Anybody heard of IPv6? Who wants to venture an explanation of what it is? Anybody?
Well, it's the protocol that replaced the IP4 thing.
Yeah, so the
No
IP
limit.
protocol is part of the fundamental networking protocols on the internet, and it's the protocol or the standard that describes, among many things, the IP address. The IP address, as you know, it looks like this, 14.28.3.0. You've seen these a million times. Every computer in here, every phone, every Google Glass, every Apple Watch, everything on there, everyone has a unique IP. Again, half-life. But everything has an IP, okay? And the IP addresses look like this. And this corresponds to 60, is it 32 or 64 bits? 4 times, I think it's probably 32 bits. Okay, now this says that there's a maximum number of unique numbers we can generate from this. Maybe, I forget, there's some number of bits. There's a limit, whatever it is, 4 billion, 400 billion, I don't know what it is. But there's a maximum, because obviously with a certain number of bits, you have a certain number of possible different values, right? So the IP protocol, which was defined in probably the 60s, it was one of the things that even came before the World Wide Web. It was how the internet itself was invented. Dictated that the format for a legal IP address was 32 bits to be parsed as 4 numbers. So what happened was, we have a lot more computers today than anybody imagined in their possible craziest dreams you would have. And despite a lot of trickery and indirection and magic, eventually we didn't have enough different IP addresses. So somebody had to come up with a new standard, a new protocol, a new format called IP version 6, which actually redefined how many bits are available for an IP address. I think it became 128, I'm not sure. But anyway, a lot more. Okay? So that's just another illustration of the critical importance of standards and protocols and formats. You all know maybe that Excel files have XLS files and they have WKS files, they have a million different file formats. So even within one product, they have different ones. Okay? What are some of the reasons why somebody would change, like why might Microsoft have changed the format or the standard for Excel files? Why might there be HTML version 1 and HTML, or HTTP version 1 and version 1.1? Why would that happen? Why would anybody have to change the standard? And I've given you the answer in the story I just told you. I have my back to that side of the room.
New innovations require changes that the previous version can accomplish?
Yeah, okay, because the previous version establishes certain very specific rules. And when you hit a point where those rules don't hold anymore, you got problems. Now imagine you had a city where, I can't make that, not a good example. Forget that. So basically you decide that, we always decided that the rules were for IP addresses that there would be 32 bits. Now you say no, there's IPv6, and it's now 128 bits. You hit another problem, very big problem, which is when I see my string of numbers, not only do I have to know whether it's IP or not, now I need to know what version it is. And because the world is big and heterogeneous, and that's the state we're in right now, 75% of all the hardware out there is talking IP version, whatever, the old version, and 25% is talking IPv6. And they're all talking to each other. And somehow that has to be kept straight. Okay? Anyway, the main thing to get out of this is the idea of standards, formats, protocols, all part of the same thing. Okay. Let's take them one at a time. Let's start with the URL, also known as the URI. URL stands for Universal Resource Locator. URI stands for Universal Resource
Indicator?
Indicator is what I was going to say, yeah, indicator. Okay, and I'll explain why. It ties into something that one of you guys said just now. So let's take apart a URL. URL is always text, although recently, I don't know when, recently, they had to come up with a new standard of URLs permitting non-Latin characters. Because why is it that a website in China should be designated by a name in Latin letters? So now you can have URLs that are not all Latin letters, but that wasn't always the case. So I'm going to pretend it's just Latin letters. And we see the components of a URL. I'm going to erase to make it a little bit more legible. Okay? So what are the components? We have the first component, and remember, this is a standard, it's a protocol, it's a format, which means this has a syntax, which means there's a parser for it, which means that you can write an invalid URL. It's got to satisfy the language specification for a URL, and if it doesn't, the thing will not understand it. Yes?
So there's the limiters, obviously.
Yeah.
Which are clearly the slashes and the dots.
Yep, exactly.
To begin with.
Yep. Actually, the slashes, oddly enough, are not necessarily hardwired. Yeah, but that's what it used to be. But I'll stick with what you said. So it's the slashes, yes. It's certainly the dots.
And anything that comes after the dot is a special thing, like
TLD. This here? Yeah. Interestingly, now this thing here is its own mini syntax. This is what a domain name looks like. We know that A.B.C. Oh, but I left out something very important. A part of the URL, which I need for my explanation. :3000 / books / date 2015. Okay, made it shorter. So we got the domain name. It's got its own syntax. You can write an invalid domain name, like a.b.com is not a valid domain name. You have this section, the slashes, which delimits the protocol from the rest. We've got this thing, which is the port number, which I'll explain in a minute. And then here we've got the path, which has a conventional but not absolutely uniform syntax, having a bunch of things with slashes, then a question mark, then some more text. Who knows why we say 2005 plus 2016? Or let me put it this better. Pedo plus salads. You've seen that. What's with the plus? Anybody?
no spaces allowed.
Yeah, the whole thing has no spaces. So there's actually another standard that says exactly how you can convert any piece of text into a valid URL text. And one of the things it does is replaces spaces by pluses. Yes?
Is that the same how, like, if you wanted to access a particular point of a YouTube clip,
yeah,
you do like 10s something?
Yeah. On the URL?
Yeah.
Absolutely. After a question mark? Mm-hmm. Yeah, exactly. After the question mark, there's a bunch of like free-form parameters that are dictated by the application what they can be. Okay? Yeah.
Is HTTP like the default? Because I know you can just type in like youtube.com or google.com.
It's not the default for the protocol. It's just the browser is being helpful. The browser puts it in for you. Okay? Okay. So these things all have a meaning and they all have a job to do, and I'm going to go through what the jobs are and the meanings are. Okay? But this is the URL standard. Okay, the second standard, maybe I will turn this thing off again to get some more room. The second standard I want to talk about is HTTP. HTTP is very, very simple. One thing about protocols is that they tend to be stacked on top of each other, which means, I've used this analogy. Let's say I send a box and I address it and I write an address on the label for Brandeis. Okay, I don't know the address correctly for Brandeis, but it's something like, you know, Tito Salas, Brandeis University, Waltham, Mass, some zip code, and let's say it also had, now we have also department, C41.131. Okay? And let's say a box arrives at the Brandeis mailroom with this. This also is a format, this also is a standard, and I'm going to show you what I mean when I say that they're stacked on each other. The people at the Waltham post office, all they care about is, they don't care about this, they care about, they pull this out, they pull this out, they pull this out, they pull this out, and they know that here's Brandeis, and there's one building here at Brandeis, and that's where the box should go. That's the top level of the protocol, the most general part. Now it arrives there, and I'm making this up because I don't know how it really works. In the mailroom, somebody goes, I don't care about everything else, I just care about department C41. I look up in a book, C41, that's this building over here. And I send the box over there. And then it arrives at the office of the computer science department, and they don't care about any of this stuff, they care about this. That's the room 131, and they know where to take it. So my point is that to the Waltham post office, all they see is this. To the mailroom at Brandeis, all they see is this. To the office at Brandeis in the computer science department, all they see is this. So you can argue that this protocol, this format, is actually a stack that has first US address, then inside, and then on top of that, it's Brandeis departmental address, and on top of that is personal delivery. Okay? If you map that into how it would work if you were trying to send this on a protocol, okay, then basically those things get nested. So the way this thing would actually end up looking would be on the outside, it would be ordered differently. It would be ordered like this: USA, Massachusetts, 02474, 41 South Street, Brandeis. That'll be on the outside of the packet. And then the next layer would be department C41. And then the next layer would be room 131. And then finally here would be the message. Okay, so there's a nesting. The post office doesn't need to understand what this stuff means because he never sees it. He says, okay, great. He takes this off and he sends this off to Brandeis. At Brandeis, they don't really care about how this stuff looks. They care about this department. So they look at that, they send it to the right place. So there's a nesting of protocols. There's a nesting of formats. It so happens that within the world of the web, the protocols that are involved, and you don't need to go deeper in those in this course, would be at the bottom, there's a protocol called IP. On top of that, there's a protocol called TCP. And on top of that, there's a protocol called HTTP. And then finally, on top of that is the payload, the message. Okay? This part gets the message over to the right computer. Once the right computer has it, this part ends up collecting a collection of packets together into a message and make sure that it's error-free. Once that's all set, then only this part is going to try to understand what the message is and do something with it. HTTP is the key one. Okay. Okay, so let's talk about HTTP. So leaving all that aside, you can think of HTTP a little bit like making a subroutine call. Okay? If I want to call a function called, conceptually now, if I have a server here, and it's got the world's best clock on it, and it implements one function. The function is called time, and the time function returns a string that says what time it is. And this server wants to allow any other server in the world to ask it what time it is. Okay? That's kind of the principle we're working on here. The server provides some kind of functionality, another client wants to use that functionality. Okay? In that scenario, you would use HTTP to ask that question. You would say, now I'm on my client, I'm on a different computer altogether, and I say call this server, let's call it the time.gov, on the server called time.gov, please ask for the method called time. Okay? And I know it's going to return a string. And this request gets packaged with HTTP, transmitted to this server. The server does its job and returns the answer back as a string. So you can think of HTTP as a mechanism to have one computer, the client, ask another computer, the server, to do something, and then get an answer. All right? So obviously it's not textual. In fact, the building blocks of a request in HTTP look as follows. So the first thing is they talk about the HTTP verb, okay, which is basically the command. And the most common command in HTTP is get. There's only a few. Get, put, post, and let's only focus on those. Get says, get me the time, get me something. Put means, I have a new value. Let's say I'm over here and I want to reset this clock to something else. I want to tell it to do something. That's put. In fact, let's just leave it at get and put. There's two commands. They both go from the client to the server. Realize this is important. Okay? I got the client and the server. Here's the client. Here's the server. I can do a get, and I can do a put. Notice the arrows both point that way. This client is asking or telling this thing about something. If he's asking it about something, the client sends a get message. If he's telling him to do something, the client sends a post message. The messages always are going this way. The answers are always coming back that way. Okay, so the first thing is get or put or the other verbs. That's the first thing. The second thing is this. It's the path. As a string of text, the path. Okay? And the third thing, there's about 100 things, okay, but the third thing is the format of the desired result. So, please get from server time, get, that's what it is. The path is current time, and the result, the desired result is text. That's a that's an HTTP call turned into text. Get, the path, and the desired result is this. Okay? And the response that the server gives to that request is going to go, wait a second, I know how to interpret this path. He wants the current time. Oh, I know how to convert current time into text. Okay, good. I'll send the answer back. If instead I say current date, the request is going to come to the server, give me the current date. No, sorry, give me a get. The path is current date. The server's going to go, I don't know what that path means. Return an error, 404. You've seen that. That's what a 404 is. Okay? So, yes?
Question. Is it when the client asks for something and it's usually some sort of method or a class or an object that doesn't exist in the scope of the website?
It could be any number of things. Because, and this, I'm going to go back to whoever said slashes. The original vision of the World Wide Web was in fact that each of these requests were just a file on this computer. And you were just asking for a file and it was returning that file. Okay? In that case, 404 meant file not found. But just a little while later, they realized that the server can be returning things that are not artifacts. They can be results of computations. So suddenly, this thing was no longer a path to a certain file on the server. It became a request, a description of a request. And that's when URL became URI. Because it wasn't locating a resource that existed. There was no resource on this computer called time or current time. It was looking at a clock and returning a piece of string. It was creating it on the spot. Okay? It became universal resource indicator, meaning that there's no promise that such a thing exists. I'm just writing an address. Just like you can write an address on a letter for a place that does not exist, you can write a URI for a place that does not exist. But when the server gets it, it's going to go, I don't know what that is. Okay? How's it going so far? Everybody caught more or less up? Yes? Anybody?
I love the interwebs.
Say what?
I love the interwebs.
The interwebs are awesome. I agree.
Which protocol is TCP?
TCP is for another class. It's a lower level protocol. I explain it to you offline, but I don't want to take time right now. Okay. And then the last of the three, of the triad of the key protocols, as I mentioned, is HTML. So it turns out that, I guess maybe 4 is a status code, which is like 404 or 200, etc. Okay? So notice that I said I have to indicate in the call text. Now it turns out that HTML is a text format. It's a text file. So there's a subtype of text called text/HTML. Okay, and that says, hey server, not only do I want you to execute this request against path current date, but I want you to return the answer in the format called HTML, text format called HTML. The server might say, I don't know how to do that. Return an error. Or it could say, no, here it is, and give it to you in HTML. Okay? That's basically how the web works. And each of your web servers, for each of your products, is going to do that. Given a URL, return an HTML file. That's it. Give it a URL. Here's a URL. Get or put. Here's the answer. That's really all a web server does. Okay? And so all the mechanism of Rails is to make it possible to build a web server like that that does those kinds of operations quickly and easily. Okay. Okay, let's play a little bit, shall we? Let me lower this thing again. Turn this thing back on. Get my chair. Pardon?
Oh, no, nothing.
Okay, so this, by the way, everything I just covered is all in this page. I think I covered it more or less exactly, maybe a slightly different order. But let me see HTTP. Here's a good one. Okay, great. Let's show you some fun things. Let me take this. A tad?
Yeah.
How many tads? Just one?
That's perfect.
Okay, one tad. Okay. This is all on this website. It's just stuff that I didn't end up using. I might use it later, but feels right to use it now. So I'm gonna, can you see everything? Yes, you can, right? So I'm gonna put this, I'm gonna put this over here. And I'm gonna start playing around with stuff that you've seen probably in your life before, but I'm going to show it to you with commentary related to what I just talked about. So first of all, ping salus.com. You've all seen this, or brandas.edu. Okay. So what's going on here? What's going on here is that I run the ping program, which is just a program on this computer. It opens a connection. First of all, it parses this domain name, figures out what the corresponding IP address is for the server, and sends a packet, called a ping packet, to that server. And all that server is asked to do is to return a piece of text that you see here that has some information, some technical information, and keeps on doing that over and over again. So that's a request and a response, request and a response. Okay? Let me show you this. Some of these links maybe, we'll see if they still work. This is interesting because and there's a million things like this. Okay, this is the map of the internet. And I told you that all of IP addresses cover the whole world, right? And so basically what has happened is, in order to keep a little bit of sanity in the world, the Internet Coordinating Committee, or whatever it's called, assigns or gives control over certain subsets of those numbers that are available to certain entities, so they can further distribute them. So you don't always have to, if Brandeis wants a new IP address, they don't have to go ask somebody. Brandeis has a collection of IP addresses, they can give them out to anybody they want. Okay. You understand the idea of an IP address. I get 32 bits. That's a number from 0 to whatever it is, 4 billion. And so every single IP address is a unique number between 0 and 4 billion. There's only 4 billion of them. There are only 4 billion different ones. And so if I want Brandeis to be able to give them out to students without having to ask with the mothership, I tell Brandeis, you're allowed to give out from number 0 to 2,000 at will. Don't have to ask anybody, they're yours. That's what this map is showing. You had a question? No. Okay. So this map is showing who has control of what parts of the world of internet addresses. Even though it's showing it in a two-dimensional picture, it's really a number line, essentially. And so in here somewhere, we should be able to find Brandeis. Here it is, right here. There's Brandeis.edu. Okay? Here, now why is it here? It's not in Japan, so it must be that it's in various. Here you have the U.S. Department of Defense. Here we have Xerox. Here we have, let's see, what's it? U.S. Postal Service. Here we have, I bet MIT is really big on here somewhere. Here's North America. Here's some more North, here's Africa. Who can tell me why a certain company or entity might appear here versus here versus here? And why would some be bigger and some smaller? Remembering that these are the names of subsets of IP addresses that different entities have been given exclusive control over. Who can take a guess? These are all big companies that existed at the beginning of the internet. BB&N was part of the creation of the internet. Bell Labs was part of the creation of the internet. MIT was a major part of the creation of the internet. So those guys grabbed big chunks of real estate for themselves at the beginning. Okay? The non-North American countries came in much later in the game, and so they got smaller. But of course, this is a lot of people, right? And that's why IPv6 comes into play, because suddenly, there's just no more room on this landscape. So this is a way to understand the idea of allocating IP addresses to different entities. Okay. Now, why is Brandeis here? I can't answer that. It's an odd place. This probably this visualization is probably a little bit out of date, is what I bet. Okay. Let me find another one I want to show you. Here we go, I think. Yes. Okay, perfect. Great. So Telnet is another utility that you type on the command line like this, and it just puts together a request based on a certain protocol and issues it. So it's a way to do any kind of request in the most vanilla sense of the word. Okay, so we're going to type in exactly this. Actually, not exactly, because it didn't format correctly. I'm going to telnet to a domain name called example.com on port 80. Port 80 corresponds, by the way, to the HTTP protocol. Then I'm going to issue. Now here's the funny thing. This is a protocol. So this is like the little numbers I was printing before. Okay? And the content of an HTTP message follows this strange little format. It's textual, which is interesting. It's not binary. You can read it. So the way it looks is like this. It says get. That's the noun, or the verb rather. Slash, that's the path. Okay? And finally it says HTTP slash 1.1, which says what language to use. Remember I talked about the versions. At the very start of the request, not only do we say the verb, not only do we say the path, but we say what flavor of HTTP we're talking. That's how the recipient, who's receiving this? Who's going to be the recipient of this message? Say up, speak up.
Serverexample.com.
Yeah, the server. There's a server at example.com. It's been there from the beginning of the internet. Okay, so if I type this, now I have to do one more thing, which is that I have to tell it in the message itself. I don't even think you need it, actually. I think you have to just give it a double carriage return, and there's the answer. Let's study this answer here for a second. So starting up here, this is where the message began. Here, get. And here's the answer. So, the answer is, that was the question. Here's the answer. It says, by the way, I'm talking HTTP 1.1. 400 is success. No, it's not success. It's bad request. I'll tell you why that is. But it still was able to do something with it. It's saying my response is in the format, the language text / HTML, as I mentioned. It says the length is 349 bytes. It says the connection was closed. The date it happened is this. The server that answered is this. And here's HTML. Boom. So, if I take this text and I create a text file with it, take this out of here. This, I took too much of it. This is the response here. That's what was in this message, right? This is the header of the result. That's the result. And I call this d.html, and I save it to my desktop. You know what's going to happen, right? Here's d.html. It's just a file. And if I open it, I get that. Compare that with, if I type example, but it's going to work when I do this. Okay, so really, if I had, and I can't get my browser to issue this request because it's an invalid request, but this is HTML. If you study this a little bit, you'll see that HTML is a bunch of angle brackets, a bunch of header stuff, blah, 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 head, and then here's the body of the text. H1 is the header level 1, bad request. Correct? That's what it said. Okay, so let's improve the request a little bit and actually follow my own example, which is that I'm going to go get / HTTP / 1.1, enter, and now I'm going to say host : example.com, enter, enter. Now, here's the response I got this time. Okay, let me go through it for you. So here's the request. Here's the response. 200 is an OK, so the status was OK. A lot of techie stuff. Eventually it comes to this. This is the HTML. So if I select this text and I copy it and I go to my text file and I save that instead, oh, there's a lot of stuff in there. Okay. Anyway, I save it, and I go here, and I refresh. Oops, and I go here, and I refresh it. Hello. Okay, try it again. Didn't I call it? .html file. Maybe this is being clever, so I'm going to get rid of that and do file open. File. Desktop. Hey, what's going on here? Maybe I've saved it with the wrong name. Let's see. Oh, I called it 1 dot. Okay, try it again. It's called file save as d2.html on the desktop. Let's try that. There's d2. Okay, and that's the answer. So if I go to example.com directly, I see the same thing. All right? So, to recap, I'm using Telnet. Telnet is manually creating the request that normally is created by the browser. I'm structuring the request to reflect a valid GET request, which includes the path. It includes, although that gets generated automatically, or I think it defaults to HTML. And it sends it off to the server called example.com somewhere in the mysterious internet. And the server sends back text/HTML, which is just text. That's this, up to the bottom. And if I was a browser, I would just process the HTML, and if it was valid, it would display. But instead what I did was I just cut and pasted it off the shelf, put it into a text file, saved it onto my desktop, and opened it with the browser directly from the file. And that's why I drew that picture. So if we analyze this, and you will, how many of you have HTML chops? How many of you know HTML pretty well? Okay, good. So there's probably several people on every team. We're going to be doing a lot of HTML. And so to play the game again, all that your Rails server is going to do, all it's going to do is, here's a URL, here's a path, and it's saying thank you, and it's saying here's an HTML file. That's all it does. Yeah?
Sorry, might be a stupid question, but obviously you knew beforehand what version of HTML you knew beforehand.
Right.
How would you, is there a way to query that and then use the correct version as opposed to?
In general, yes. But you bring up an interesting point. If you request the wrong type of format from a server who does not know it, it's going to give you some kind of failure. Okay? And so, for example, I'm going to just try this. I don't really know if it's true. I'm going to try, for example, here saying https://. Oh, it knows how to do it. But if you could give it something it did not understand, well, let's try putting that. Didn't do anything. So, but in general, the other thing that's interesting is you bring up a pretty subtle protocol design challenge, which is fallback, which is what does my server do if it asks a question of something that's in the wrong version? And if you imagine the world of smartphones that are all talking protocols to their servers, and if I ship a new version of my game that's talking to the server that's the back end to that game, and I just upgraded that server to a new protocol because I have new features in my game, but there's still a million people running the old version, and they're just going to talk to that server as if nothing's wrong. Somehow you have to, as an engineer, as an architect, accommodate that fact and realize that you may be getting requests from servers that are not up to the latest version, or vice versa. You could ship a new version of like there's a Latte, believe it or not, iPhone app, and you could try to connect it to somebody running an older version of Latte, and what happens then? So those version management and version negotiations are very, very tricky business. So in general, the answer to you is the server will say, I know how to talk this or not, and just fail. Okay? Now sometimes there's a special protocol they call a handshake, where you go like two people, like I meet you, I say, I know how to speak English, Dutch, and Papiamento. You go, I know how to speak Dutch, French, and Chinese. I go, let's speak Dutch. That's how that works. That's called a protocol negotiation. Yeah?
What did you on the first one that gave you an error on the second one?
I
think I missed it.
I didn't explain it. I glossed by it. It turns out for, I think, something to do with not security, but kind of like protection, that nowadays, maybe it's a factor of HTTP 1.1, you are required as a parameter to give the name of the server that you want to request to this. Not only, so I skipped here, there's like 2A here. I mean, there's literally 100 parameters, 100 possible things. But in addition to the path, there's also, I think they call them parameters. And the parameters look like this, like host : this, content length : this. These are all parameters. These are response parameters. So the server, I think it has to do with security or something like that, requires that you include a parameter of the name of itself. So if I go through and do the same thing again, just to show you, and let's do a couple of other variations actually. Go here again. Oops. Yeah. Okay. So let's try get /http/1.1. Okay, and we get a bad request. Okay, and if we look up what bad request is, we go over here and we say HTTP. Was it 400? It was 400, right?
Yeah.
400 error. Bad request could not be understood by the server due to malformed syntax. Okay, and so basically it considers that literally a bad request. But let's do a couple of other and so that's why it did that, because that thing was missing. But let's do a couple of other variations on that same theme. Let's say instead we say get /http/1.0. Now we get not found. Okay, so it considers this. It doesn't even know how to parse the. Oh, I didn't do it. Okay, get /http. What is it? /1.1, 1.0. Is that what it is? These things are very particular. Yeah, HTTP/. Okay. Instead, not found.
You need to put hostexample.com.
Sorry?
You need to put hostexample.com.
I still have to say that? Okay, let's see.
It gives you like a HTTP version.
Get / my theory was that host : example.com. Now it says it works fine. So I was hypothesizing that HTTP 1.0 did not require the host.
0.9 won't.
0.9 won't. Okay. So that's the world of multiple protocols, and that's where the rules are very. I mean, there's an organization called the W3C, the World Wide Web Consortium, that is responsible for writing up these protocols and these standards, and they're like legal. They are legal documents. They go on for hundreds of pages. Okay, but we don't have to worry about that. Okay, I'm basically running out of time here, so it's all on the page. But let me just quickly talk about. See if I missed anything. I think I basically covered what I wanted to cover exactly. Right. It's all here. Okay. So so tomorrow. Yeah, it's tomorrow. It's tomorrow. Yes, tomorrow. So tomorrow we're going to do the project kickoff. This has some tricky homework on it, so beware. And this is important, even though there's only one day. Get together with your team and start sketching out. Read these articles, they're not very long, about paper prototyping and UX flow. Paper prototyping is just what it sounds. Take a screen, draw it on paper, say this is the label, it says login, there's a box, there's a request password, whatever. And UX flow means let's make 3 of these or 10 of these. How do we get from one to the other? And we'll do more of this. I want you to start thinking about this so we can talk about it tomorrow. Okay? But fundamentally, what we're going to do tomorrow is go over this. Most importantly, the project roadmap, where I gave you a rough idea, not a detailed idea, but a rough idea of all the steps we're going to go through between now and the end of the course, which will give you an idea of the right order to attack things and also the things you have to look at. Some of these steps will not apply. We'll talk about it tomorrow. Okay. I think we're all set. Any questions, last minute questions? If not, I will see you all tomorrow, hopefully, as long as there's no snow again.
When are you guys? All three.
Yeah, sure.
So I was looking over the deliverables for 105 for another class.
Yeah.
Sorry. So I found this one, but I don't remember it being on the class website. I was always looking to find it.
Oh, it's there. Okay.
Because the one from 6 days ago. So I definitely